My name is Elvin Nurul Rahmayani, NPM 20130222038. The first, work by constant force. Suppose we have an object and we are applying a constant force in the horizontal direction. We would now like to introduce the concept of force. Suppose our force starts at a point xi and goes to a position x final, and we'll call this the I hat direction. Then our force as a vector will write fxi hat like this. And now, what we'd like to calculate is the product of force with the displacement of the object. So our displacement vector delta x is equal to delta x I hat, where delta x is equal to x final minus x initial. And for our constant force, for the case where fx is a constant, fx is a constant. So we see work is a scalar that has a segment quantity, positive or negative. Now whenever we introduce a new quantity, we always have to be a little bit careful about the units. Since work is the product of force and distance, then our SI units for work are the units that our SI units for work are the units of force, which are newtons times the unit of distance meter, and we call this a joule. So 1 joule is equal to 1 newton meter. The second, work by a non-constant force. We already defined work in one dimension is the product of force times displacement for a constant force, but now let's look at a case where we are applying a force F that is a function of x. So our component f of x is a function of x in the I hat direction. And one of the simple example like this is what we call spring force. Now when we apply this force to our object, and let's look at an object A. I hat direction will have an origin, and this our plus min x coordinate system. And that is what we define to be the work for a constant force. Third, we are going to do so by using Newton's second law, but we are not going to consider it with respect to time as what we've previously done, but we are now going to consider it with respect to speech. Second law. So F equal ma, and we are going to take the x component of that. This is the change in kinetic energy. The last is kinetic energy. We're calling kinetic energy K, and it's given by 1/2 mv squared. And this is a scalar quantity, so it's going to be either 0 or positive. It's never going to be negative. The SI unit for kinetic energy is joule. So we have 1 joule here for kinetic energy. So how can we pair up momentum and kinetic energy? The formula is like this. And so we are going to get that actually can be expressed as P over 2m, and so that is the kinetic energy. Okay, I think enough. Sorry if I made a mistake. See you.